Hello, everyone, and welcome to a new IT Ops Times live micro webinar series. This one is on AI and network engineering and operations. Our first session of the series today will look at the impact artificial intelligence is having in the IT space, networks, operations, and data. So to kick the series off, Phil Gervasi, he's the Director of Technical Evangelism at network observability company Kentik. And he'll be diving into the essential aspects of AI and uncover the practical realities of its use in network engineering, NetOps, and network architecture. Just to let you know, this episode and the rest of the series will be available on itopstimes.com in the Learning Center, available on demand and for replay. So thanks for being here. And Phil, let's get started.
Great. Thank you, David. Yeah, I'm so glad that you said the practical reality of artificial intelligence in IT operations, because that's very much what we're going to be focused on today, getting a little bit, putting a little bit aside the hype and some of the marketing around AI, and really looking at what are the benefits of artificial intelligence in IT operations. And then my background, which is predominantly in systems engineering and very specifically network engineering, specifically looking at how the field of network operations, which is very broad today, benefits from artificial intelligence. But before we get really into it, I'd like to demystify and go over some taxonomy, some terms. So the term artificial intelligence, I think it's important for folks to understand that it really is a general sort of overview term, as you can see on the left box there, that really refers to a collection of technologies, actual technology, and also workflows and processes. There's hardware involved. There's workflows of how data gets moved around in data pipelines and telemetry pipelines, ultimately referring to the simulation of human intelligence by machines or computers. Now, I put a little star next to that bullet. So if you see that there, what I mean by that is that I have a good friend who's a PhD in neuroscience, and he will be the first one to say that we don't really truly know very well how the human mind works. So how can we simulate it with computers? So what that star means here is that we're not necessarily trying to emulate a human being's thinking and how human beings think. One, because it presupposes that we know completely how they work, how human minds work, but also, number two, we want to do it better. So the real goal of artificial intelligence is this overview of processes and technologies that can ultimately end up with the result of what a human does when they think, the insight, the correlation that they can do in their mind, the decision-making, the analysis that a human being does, except faster, more accurate, and better. So it's the result that we really care about. So artificial intelligence has a couple of different camps here. We have general AI, also known as AGI, artificial general intelligence. And that's much more concerned with data processing. It's much more concerned that's probably more akin to what folks think of when they think of AI and when they think of AI sort of taking over the world, like Skynet and all that sort of thing. So a very broad intelligence, which ultimately some people are predicting will lead to a superhuman intelligence, which is SAGI, artificial general intelligence, but ultimately resulting in the analysis of data and then doing some sort of action. What we're focused more on today, and what the world is really a buzz about today, is generative AI or Gen AI. And they are not two distinct categories in that they're different. They are certainly related to each other. Generative AI is a type of a subset of what's called narrow AI, or artificial intelligence that's more narrow in scope, typically dedicated to a specific function. And so what we're going to talk about today in generative AI is the analysis and the analysis of data, but specifically text data, and how that can help IT operations. Now, we're going to talk about more than text data for sure, but that's what we're going to start with right now. So generative AI, as many of you know, we've been using it with tools like GPT and then Chat GPT, and Google and Facebook or Meta have their tools, and there's some other ones out there. And we're using them for things like creating new content, for summarizing documentation, creating code if you're in the IT field. And now we're expanding beyond text into video and music and things like that. So if you think about AI as the broad term, you see here the blue circle and then the concentric circles subsequent to that. Some of the technologies that we're talking about within this subset of AI are going to be things like machine learning, deep learning, and neural networks. Now, of course, if we had unlimited time, we can break down these individual categories into very, very atomic processes and very specific technologies, like specific ML models. And if you think back to maybe your own college days when you took a statistical analysis class or a calculus class, and you learned about things like linear regression and the Holt-Winters model or algorithm, rather, these are the things that we're talking about here. And so this is a very data analysis focused process that we're going to be applying to IT operations to solve specific problems. So I have here on the screen for you a few definitions that you can use to sort of get your idea or get an idea about what is this all about? Artificial intelligence, AI. Well, think again about AI in a broad term. And what's happening under the hood is that we are ingesting a tremendous amount of data, and we're using algorithms and machine learning models to do something interesting with it, find some meaning in that data, and then ultimately produce some sort of an output. The output that we might be familiar with a tool like ChatGPT might be some new text or a summary of data, but it also might be more mathematical in the sense that we're finding correlation, strong correlation, weak correlation, identifying patterns. And you see here, deep learning is I say nothing more. That's a trivial way to put it. Nothing more than the collection of all the individual activities, the individual algorithms running all together in sum total to actually teach the computer about what this data means. And then the neural network is the interconnection of all these tasks and all these things that are happening. And so let's move on and start looking about how AI ops actually looks. Now, AI ops was coined a few years ago, and many relegated it immediately to a marketing term that meant very little. But I would argue that, especially with the advent of large language models today, it means very much, and it can be an incredible asset to an engineer. So what's happening in an AI ops or AI operations workflow is the application of artificial intelligence processes and technologies to whatever you're doing in your operational context, whether that's cloud, network, IT operations as a whole, which I think you're going to see as we move forward is really where things are going, since we can ingest all of this data into one platform. So starting from the left, it really comes all down to the data. We're ingesting a tremendous amount of data. So for network operations, it might be things like information from SNMP and streaming telemetry and logs and syslog and all this stuff from network devices and firewall logs and AWS VPC flow logs, whatever you like, and metrics like interface statistics and counters and CRC errors on your router interface, things like that. Even configurations, considering that configurations are text. What you'll see then as that's ingested into a platform is some sort of enrichment. Now, for what we're doing with the application of AI to network operations and to IT operations is the enrichment with relevant data. So things like routing tables, DNS information, perhaps customer tags, application IDs, security threat feeds. It really depends on the context and the application, but all of that kind of information. And now you start to get into the math and to the code, where we are looking at embedding basically algorithms into Python or whatever code, or Go into various Jupyter notebooks and whatever folks are using to standardize that data, normalize it, and then ultimately transform it so we can do something interesting, analyze it. Now what's happening is in this entire workflow, we are using things like linear regression and autoregression, time series family of models. We're using gradient descent to identify how accurate or inaccurate our results are. So there's this constant feedback loop of back propagation that is helping to ensure accuracy. We're using models like transformers and neural networks to facilitate deep learning, and all of this ultimately to lead to our result all the way on the right is to produce some sort of meaningful insight into the data. So we have all these data points. Who cares? I want to know what kind of trends. Why is my interface errors, packet loss going up? What we had BGP prefixes pulled or pushed. Why and how is changing traffic from data center A to data center B? Why is that resulting in a latency spike for my users in Singapore? There should be unrelated. And so we start to be able to do some very interesting things because of this entire process, data enrichment, pre-processing, and analysis. It could be as mundane, though, as sending an alert to your ticketing system, which I say mundane tongue-in-cheek. It's very, very important that we're getting these alerts about things that are happening because of the data that we're able to analyze through this AI ops workflow. Now, large language models in particular is a large language models are a subset, and they rely on something called natural language processing that allows a human being to interact with data, specifically text data, very, very naturally. So we train a large language model primarily with text data, text-related data, but that can also be more broad than that. There are large language models are now drawing in other types of data, but it could be web-based configuration files and that sort of thing. As that data comes into the model is trained in this gigantically expensive and large data center where the model is looking at the data and going through this iterative process of back propagation to be trained. Once the model is fit for service, meaning it has been trained, which can take months to do and is very computational and resource expensive in terms of cost and GPUs and that sort of thing, we have a model that we can run data through. And so the result is we can now use that model to summarize text for us, to analyze network data, whatever it happens to be, and allow a human being to interact with data in a way that's faster, more efficient, more accurate than ever before. And this is why I think that the application of artificial intelligence, specifically generative AI and large language models, is really changing the nature of IT operations today. So what are the benefits? We have faster data analysis. We can organize data and find anomalies and find correlation faster and better than we ever have before, unless you have a team of 20 PhDs from MIT. And even then, it's going to be slow because you're encumbered by the human activity. You can identify security threats and vulnerabilities, compare real-time data, historical data, find benchmarks, baselines, all of that stuff very quickly and easily. And then you can use the results of that to alert your network operations team to take some sort of action, or you can start to integrate some of those really interesting AI tools, agents that are out there and that are starting to be developed to automatically push config changes, to continually fine tune and programmatically monitor the network, and ultimately provide a better service. And then lastly, all of this is adding a layer of intelligence to network operations that is just very difficult to do with time-constrained teams, resource-constrained teams. So identifying trends, identifying cost increases, and what changes in configuration led to my AWS bill spiking, and very relevant things like that. And it gives context to all this data. So this is a slide, or an image rather, from Gartner that shows a couple of the benefits here. You can see that we have real-time historical data coming in from the left, on the left side, used in AI operations in kind of this traditional big data context to do analyses on the data, find correlation, locate anomalies, outliers of the norm, and then feed that into other systems to create incidents, to identify where changes or optimizations can be done. Whether that kicks off an automatic thing, you can see in the lower right, scripts run books, and whatever happens to be that your organization uses, or again, alerts an engineer. So this is something that is very relevant to day-to-day operations. So some of the challenges that we're seeing with the use of generative AI, specifically large language models in IT operations, is that sometimes there's a struggle with accuracy. There's a struggle with complexity and scalability. How does a hospital system, where I live in New York, with let's say 10,000 end users, which is a large organization, how do they afford $1 billion data center to run their own AI workloads? Well, they really can't. So how do you leverage AI? There's a problem with cost and complexity, and a cost and skills gap. And then integrating with change management. Do I trust this system to push config or not? I mean, how long do I have to wait for seeing good results before I trust it? So there's a culture issue to figure out. Of course, security and privacy. If I'm now feeding it data from my own organization, I use the example of a hospital. Is that information private? Who's owning it? Where is it going? So this is a lot to think through. And of course, the legal and ethical considerations. Is it ethical for me to push configuration over a network automatically from a system that was programmed by people, and I don't know who they are, and it could be in a healthcare situation where there's lives at stake, or a 911 situation where your emergency services in your municipality are at stake. So there are considerations here. And on the right, you could see the 4 pillars of AI strategy, again, from Gartner, but it's the idea of weighing these things out against the value. What is the vision of where we can go with this? So the way I see it is that leveraging AI ops for IT operations, or artificial generative AI for IT operations, does not replace engineers by any means, but only gives us another tool in our toolbox to do our job better. So some best practices are that engineers and business leaders, technical leaders, can look to solutions that have already built, whether those are on-prem or a SaaS offering, an AI ops platform. If you're building your own, you certainly can, but rather than building your own trained model, which again can be in the billions with a B to do, you can leverage services out there, for example, GPT, and they have an API that you can hook into and then start to utilize their AI model, their large language model, for your own purposes. And then you can augment that model with what is called a RAG pipeline, a retrieval augmented generation, which gives the context of your organization, your specific data, your network devices, your customers, and it integrates with that so that you have very context specific large language model results. And ultimately, one of the most important best practices to consider is ensuring the quality and the relevance of the network telemetry that you're ingesting. And so that's always a process of iteration, and really the key of eliminating things like hallucinations and making the process of generating results as accurate as possible. On the bottom there, you could see a very simple diagram that I put together about how a RAG pipeline works. A large language model that you're using, like a GPT, for example, is static. You're not making changes to it. You're certainly not making changes to it. But what you can do is augment that data with your own proprietary data. And so you have this closed loop of data pipeline where ultimately you embed that contextually relevant data, like your own routing tables, like your own customer tags, like your own network device information, and all of that to produce a result that is actually relevant. And then combine that with the power of GPT or some other language model that can actually allow you to use natural language to interface with the data, gives you a very powerful tool as an engineer, which is why I say that some of the best practices, the best ways that we can use large language models and generative AI moving forward in IT operations is an assistant to augment an engineer. Imagine the ability to interrogate data so much faster than you can manually. Whether you're a team of one or a team of many, this is light years ahead. It also allows you to democratize data among teams. Imagine a help desk being able to use natural language to just interrogate the data like you see on the screen, as opposed to having a requirement for a very high level engineer who knows all the terms and all the syntax of whatever Juniper or Cisco or Arista platform that you're running so they can do this. Now you've also allowed the security team and the application team and whoever else to be able to access that same information very easily. And so as we move forward, I have a very, very brief demo that I'd like to show you of a couple of examples from my company's platform that shows how you can use a large language model in IT operations. I'll swing my screen over here. So this is called Journeys AI. Journeys is just our name for the ability to ask any question of your network and then interrogate the data on a journey, so to speak, of finding out what's going on. I have on my other screen some questions I'm going to ask our system already copied, and I'll paste them in. So a very simple question. I want to see all the traffic in my network broken down by provider. Well, I can just ask the system that. And there really isn't any need to understand all the different providers or to understand the configuration or the context or the syntax in order to do that. I can just ask in normal language, and you can see I have some interesting results here. Let's say I want to look at specific information like interface utilization. Well, I can do that. And let's say I even want to give it a time frame. I want to see that utilization in the last 15 minutes. Again, I'm not thinking about syntax, and I don't need to be a network person, and I can do that very quickly. Let's say I want to, it's interesting information, but I want to fine tune that rather than start over, because what's happening under the hood here is it's generating the queries for you. I can just add to that previous query, just like we do with a tool like ChatGPT, where you can continue the conversation. It's the same question. Show me, where is it here? Show me interface utilization by devices for the last 15 minutes, but only where utilization was greater than 20%. You can see that I have that ability to have that journey, that conversation. I'm going to switch over to my query assistant in Metrics Explorer and show you a little bit more detail about how deep we can go. So you can see here in our search field that we can query data effortlessly with natural language. That's the point. So let's say I want to see interface utilization by device. And you can see it'll spit out, again, regardless of vendor, whether it's a Cisco router, an Arista switch, or a Juniper firewall, it just spits out the information. I said device. But let's say I want to add to that and say, well, you know what? I want to include capacity. It's the same thing where you can continue that conversation and it will take that filter and expand upon it for you in natural language. If you work for a service provider, a very large organization, perhaps you're interested in BGP and you want to see all the BGP prefixes sent and received in the last day. Well, we can do that as well, again, using natural language to interrogate a massive data set of routing tables, of metrics, of customer tags, of interface descriptions, of everything that we ingest as a network observability company. And there's your answer with the entire table. And here on the right, you can actually see the filter that it built for you. So that being said, I'll take this and go back to my slides and end there. And thanks very much for your time.
All right, Phil Gervasi, Director of Technical Evangelism at network observability company Kentik. Thank you so much, Phil. Great presentation to let people know like what's real now, what they can do now with things that are already out there. So well done. So I'd also like to thank Kentik for sponsoring today's program, and of course, thank our viewers for being with us. Join us next time when we'll offer advice on the essential features and considerations for integrating AI into your network engineering and operations roadmap. Until then, I'm Dave Rubenstein, Editor-in-Chief of IT Ops Times. So long for now.